Hi guys, I'm Matt Best and welcome to my vlog. In this vlog I will identify skill and capacity issues in regards to speed and agility tasks. A skill issue is identified as a poor motor control or unfamiliarity to the exercise, whereas a capacity issue is related to restrictions in mobility and force capabilities. Firstly, I examined two athletes performing the 30-metre sprint exercise. These two athletes have similarities in regards to their anthropometrics and positioning in their sports. In this task, both athletes completed the sprint in similar times and recorded max outputs of 8.9 meters per second. However, when analysing the mid to late stage acceleration, variations are observed. The first athlete shows adequate skill during mid to late acceleration. His ankles remain stiff and good force propulsion through triple extension is apparent. His centre of mass is in front of his body and is able to remain in a forward trunk lean position. However, his ground contact times on steps between 6 to 9 is 0.144 and 0.27 seconds, identifying that although good skill is apparent, greater ground contact times is necessary to produce the force required. This increase in ground contact times is apparent to enable the athlete to produce sufficient horizontal impulse to propulse him forward. However, this increase in ground contact times expends greater energy due to increased braking forces. Further screening of this athlete identifies poor calf capacity and poor hamstring strength. This graph produced by his Norboard scores identifies asymmetries within his hamstring strength. The next clip shows poor capacity to work into end of range hip extension and flexion. This video identifies various attractor states to complete the tasks. During hip flexion, the athlete externally rotates ankle to aid the movement, and during hip extension uses a lordotic position. These capacity issues could be affecting this athlete's ability to produce force through full range of motion. This lack of end of range strength could be a factor for increased ground contact times during acceleration. Exercise interventions prescribed to this athlete are to address strength deficits and ability to utilise his stretch shortening cycle. Firstly, this athlete has been prescribed a max strength lower limb program as well as low level plyometric work. The pogo jump was prescribed to this athlete, however had to be regressed to a gymnastic floor. The use of a gymnastic floor was to aid the spring-like action of the Achilles tendon as well as optimising his technique. Specific exercises targeting triple extension and flexion have been implemented as well. Finally, once progression of max strength and usage of the stretch shortening cycle and competency to load into end of range movements are achieved, special exercises such as med ball dives, hill sprinting and resisted sprints would be implemented. These exercises challenge the athlete to overcome constraints as well as targeting greater capacity and usage of the stretch shortening cycle. The next athlete has a skill issue during mid to late stage acceleration. As seen in the video, the athlete is unable to remain in a forward trunk lean position and is unable to drive knees into triple flexion. Also, it has been highlighted that the athlete's centre of mass is behind the stance leg, creating greater braking forces and reducing force capabilities. Finally, the athlete also has poor core and upper limb control and coordination, seen by the athlete rotating trunk to try and aid force production, and poor arm extension reducing rhythm and momentum through his upper limb. These variations utilised by this athlete are to enable him to have greater ground contact times. The lack of skill in this task has caused the athlete to develop a pattern where he fails to coordinate and prepare his foot and ankle complex before ground contact. The lack of preparation to cock the foot causes heel to drop flat to the ground, reducing potential elasticity of the Achilles tendon. The athlete presents with adequate ankle dorsiflexion and hip mobility. This modified Thomas test identifies adequate hip extension capabilities. Furthermore, force capabilities by this athlete are adequate. Calf capacity testing, Norboard hamstring strength and isometric max hip extension identifies great force capabilities. This athlete has shown to have good mobility and force capabilities, but lacks skill in regards to acceleration. The pogo jump helps identify this lack of skill. The athlete achieves good height, but uses long ground contact times and various attractor states to achieve the movement. This exercise identifies the reduced efficiency of the elastic energy potential through the Achilles tendon and the stretch shortening cycle. Exercise interventions used to develop skill of this athlete firstly began with a simple banded knee drive, cueing stiffness through ankles and trunk, and to keep a forward trunk lean position. The athlete then progressed to various running drills to familiarise greater technical controls. A and V skips and ankling drills with cues of stiff ankles and high knee drives were implemented. The A skip was implemented to improve the athlete's skill and coordination with quick ground contact times and high triple flexion. The B skip was also implemented to improve the rhythm and the pawing back motion from high hip flexion to hip extension. Finally, to encourage the athlete to remain in a forward trunk lean position, resisted sprint was prescribed to overload the acceleration. This overload causes the athlete to lean forward and move his centre of mass ahead of his stance leg to aid forward propulsion. Also, cueing stiff arm drive and stiff ankles to incorporate the stretch shortening cycle is necessary during this task. This athlete demonstrates good skill with this task. The player is able to decelerate within the minimal ground contacts and is able to distribute his centre of mass over his inside leg. Also, the athlete demonstrates good technical control with the 180-degree turn. The player remains in a low and forward trunk lean position, whilst eliciting full triple extension. In turn, this allows his knee to drive through the movement, improving efficiency of the movement itself. However, when analysing the left side, the player is able to complete the task well, but unable to produce effective propulsion. This athlete is currently experiencing patellofemoral pain. These symptoms could be present due to a lack of eccentric strength of his quadriceps and poor hip capacity. When decelerating, his left knee slightly collapses and moves into a valgus position, and also it shows his hip drops into an adduction position, reinforcing a lack of hip capacity. This player has been prescribed a modified strength program with additional blood flow restriction training. The goal would be to improve hip capacity, quad strength and hypertrophy without compromising the patellofemoral joint. Hip thrusts, quarter and decline squats, as well as rear foot elevated split squat can target quadricep strength and eccentric capabilities, hip capacity work without compromising the joint. Blood flow restriction training coupled with leg extension is utilised to protect the load compromised joint. The low intensity loading reduces stress through the open kinetic chain, and the blood flow restriction targets specific hypertrophy and strength of the quadriceps. Once adequate strength and hypertrophy has been gained, as well as patellofemoral symptoms dampening down, plyometric interventions would be introduced. The plyometric intervention will aid the athlete's rate of force development. I have used myself as an example of poor skill and coordination during the T-test agility task. When completing the task with no technical cues, it is apparent that the task is unfamiliar and the technical model is far from efficient. I am unable to decelerate within the desired position and unable to manipulate my centre of mass over inside leg or the midline. The inside leg collapses in to aid the deceleration, furthering the energy leakage of this technical model. The next picture shows an inability to drive my knee across my body to create an efficient turn and high force outputs. Instead, small shuffles and an upright posture is used. In this position, the ability to produce horizontal force is poor, which is shown by the speed of completion of the task. These skill issues can be addressed by various coaching cues and exercise interventions. As shown on the right hand side of the drill, cues can aid the motor control. Firstly, cueing to keep the centre of mass over inside leg and to absorb the force with the outside leg aided the ability to decelerate within the desired measures. These cues help with the aspects of the technical model, however, I use a trunk lean and a kyphotic posture to manipulate the centre of mass. Second cue of driving the knee across the body was used, however I was unable to elicit full triple extension and used a more upright position to propulse myself. This identifies further skill and potential capacity issues. To improve these skills, further I would regress the task to a lateral shuffle and work closely on adopting better motor control patterns. Also, exercise interventions such as the lateral bounding will help increase rate of force development and improve the technical skill. Within the screening of these athletes, it is apparent that each have either a skill or capacity issue. However, there is an overlap between the two, in which both aspects should be identified and interventions should be implemented. It is also apparent that athletes showing skill issues could have adopted these motor control issues through previous capacity limitations.